This PowerPoint covers volume of solids, so we're going to see right prism and cylinder volume, pyramid and cone volume, the sphere volume, decomposable solids and volume, and units of conversion for both volume and capacity. So first we're going to talk about the volume of a right prism and a right circular cylinder. So here are some examples of prisms. Cube is actually in this category, and a right circular cylinder. The rule is area of the base times height. So find the volume of the following solids, and I actually encourage you to pause this video and do it on your own. Here's a right rectangular prism. Its base here has a dimensions of 6 and 4, and its height is 2. Remember that the volume is area of base times height. What would you do? If I calculate the area of the base, it's 6 times 4, and the height is 2. So times 2, I get 48, and in this case, very important, centimeters cubed. What about this right triangular prism? You can see that the bases are in the form of triangles, and you can also see that the height of the triangle is 10 millimeters, the height of the prism is 17, and the length of the base is 26 millimeters. So remember, area of base times the height. Because we have a triangle as our base, the area of a base is going to be base times height divided by 2. So 26 times 10 divided by 2, and the height of the whole prism is 17, so you get 2,210 millimeters cubed. For a cube, it is area of base times height, but if you notice I gave you a cheat sheet, but there's another way of calculating it. You can do the area, you can do the sides cubed. It comes to the same thing, because here, see how we have 4 times 4 times 4, which is also known as 4 cubed. You get 64 centimeters cubed for the area of a cube. A right circular cylinder here, the important thing that you need to realize is that a cylinder has a base in the shape of a circle. So when I calculate area of base, remember area of a circle is pi r squared. So in our case, it's going to be pi times 3 squared times the height of the cylinder, which is 7 centimeters. And using pi as close as you can, but usually in class I ask you to just use 3.14, but you should get approximately 197.92 centimeters cubed. Now let's talk about pyramids and cones. It's the same thing as prisms and cylinders, except we're dividing the area of the base times the height by 3. Let's look at some examples here. I'm going to give you a right rectangular pyramid, so it's got a rectangular base with a height of 12. So we're not dealing with slant height like we did for area. We are actually dealing with the height. So remember, when you stand right inside of a pyramid or a cone, right in the center of the base, and your head is basically touching the tip. So in this case, area of base, very simply, the base is a rectangle. Remember though, if you're given a polygon, you have to remember the rule for the area of a polygon, perimeter times the volume divided by 2. So in this case, the area of the base is 7 times 9, and the height of our pyramid is 12, and we divide all that by 3. Now keep in mind though, sometimes you may be given the slant height when you need the height. So remember that you can use Pythagorean's theorem, or Pythagoras' theorem, and you can solve a squared plus b squared equals c squared for whatever it is that you were looking for, whether it's the slant height or the height. An example for a right circular cone. So again, you're given the height, it's 9, and you know that the radius is 5. And just like the cylinder, your base is in the form of a cylinder, is in the form of a circle. So you have to do pi r squared for area of base. And same thing as I said for the right pyramid. Whether you're looking for the slant height or the height, notice that you are forming a right triangle, and you can use Pythag. So in our case, area of base, pi 5 squared times the height 9 divided by 3 gives us 75 pi, which is approximately 235.62 meters cubed. The volume of a ball or a sphere is very simply 4 pi r cubed, not squared, cubed divided by 3. And if you were curious for the volume of a hemisphere or half a ball, it's 2 pi r cubed divided by 3. Here's an example. I have here a ball with a radius of 15 decimeters. And if I just plug it into my formula, I get 4 times pi times 15 cubed, which gives me 4,500 pi, which is approximately 14,137.17 decimeters cubed. Now let's talk about finding the volume of a decomposable solid. So unlike finding area, we include the bases when we want to find the volume of a decomposable solid, because it's not like area where we couldn't pick a base or so, volume includes just the inside of the solid. So here's an example of a decomposable solid. This solid can be split into a right circular cone, a right circular cylinder, and a hemisphere. And remember, volume is what's inside. So base or no base, we include everything. So in this case, we're going to just decompose it. So you can tell here that I have a height of the cone is 18, height of the cylinder is 12, height of the hemisphere is 6, but that's also known as the radius. So keep in mind that that's the radius for every single shape. So here it is decomposed, your cone, your cylinder, and your half ball, your hemisphere. Cone has a height of 18 and a radius of 6. Cylinder has a height of 12 and a radius of 6, and the half ball has a radius of 6. And we just put all the rules that I just told you. Right circular cone, area of base times height divided by 3. Cylinder, area of base times height. And half ball or hemisphere. What they did is they used the original 4 pi r cubed divided by 3 divided by 2, but it's the same thing if you did 2 pi r cubed divided by 3. You just plug it into your calculator, get approximately 2,488.14 millimeters cubed. Now you've seen conversion for side lengths, which is general centimeters, meters. You've seen conversions for squared, area, meters squared, millimeters squared. But now we're going to talk about volume. Volume deals with the unit cubed. So instead of multiplying everything by 10 or multiplying everything by 100, cubed actually goes up and down by 1,000. So in this case, if you are going from, say, a decameter to a decimeter, you're going to multiply by 1,000 2 times. Or vice versa, if you're going from a decimeter cubed to a decameter cubed, you would divide by 1,000 2 times. When we're dealing with volume, we're dealing with capacity. How much stuff fits in the solid? And this is actually something that comes up a lot in science or just cooking, right? When you're cooking something, you want to know how many milliliters, how many grams, how many liters. These are the units of capacity. So these are all in liters, so kiloliters, liters, deciliters, centiliters, milliliters, kiloliters, these all exist. And if you're going up just by these simple liters, no squared, no cubes, you multiply and you divide by 10. But the reason why this is important is when you're dealing with volume in terms of the meters, 1 decimeter cubed is actually 1 liter. 1 meter cubed is 1,000 liters. And 1,000 milliliters in terms of capacity is 1 liter. Now these will come in handy when you're doing certain questions and you're asking to convert from meters cubed to liters. So for example, if you're given a question and it says, can you convert the following answer into liters? And your answer is actually in meters cubed, you would multiply that by 1,000 to get you how much it would be in liters.